Okay, hi everyone. So today I'm going to show you how to run Modeler. Modeler is a software that we use in homology modeling in order to predict the protein tertiary structure. So I'm using a Windows-based modeler here where it works using a command prompt. Okay. So I'm not going to show how to install Modeler. I expect that when you are watching this tutorial, you have already successfully installed Modeler in your laptop or your PC. Okay, so as you know, Modeler requires three files only. The first file is the template file, which is in PDB format. The second file is the sequence alignment file, which is in PIR. In the format of .ali. It has to be .ali. You cannot leave it as .pir or .aln or .txt. It has to be .ali. So this is the sequence alignment between your template and your target. And then the script file, which is, you can name it any name you want. So I'm calling as model default. So the format is in python.py. Okay, once you have all these three files, let's look at the files. So this is the script file where you have to edit only this part here, the part that I'm highlighting this one. So these are the one that you need to edit. So this ANN file, you have to provide the full name of the file. So in this case is alignment.ali. This is my alignment file. So if you are putting your alignment file, let's say your name Rachel1, so it has to be Rachel1.ali. It depends. Okay, so knowns here are the code for the template structure. So in my case, my template is 10nj, and for the sequence, this is the code for my target, which is, in this case, it's 3EBX. So this one and these two codes, it has to be consistent with whatever you are written in the alignment file. So this is the alignment.ali. The first part here, there are two parts here for the two sequences of the protein. The first part is for the template structure, okay, 10nj. So the code is 10nj. You can see that it is tally with this code here, 10nj. It has to be the same, okay? So this is the codes of the templates. And then the next one is the sequence for the target, which is in this case 3EBX. You can see that it is tally with the one that we have written in this script file. So the code of the target is 3EBX. So whatever that you write here, it has to be the same with this part. And whatever that you write at the top part here, the one that I'm highlighting, it has to be the same with this part. It needs to be the same. If it's different, then the whole simulation will crash. Okay, there will be error. Okay. Next is, I'm going to explain about the second line here. As you can see, there are like 1, 2, 3, 4, 5, 6, 7, here 7, 8, 9, 10. There are 10 fields here with 9 columns, okay, with 9 columns. So for the first field, it is mentioned either structure X or sequence. So this, the first field, it tells the program if this sequence, it belongs to the target protein or the template protein. If it's the template protein, you have to specify the first field as structure X. If it's the target protein, so you have to put just sequence so that the program knows the first sequence here is the template or the target. Okay, so that is the first field. Now the second field, which is this one, is simply the codes of the protein. And you are free to name your proteins with whatever codes or names, but it has to be tally with the one that I showed just now in the script file. It has to be the same. Okay, so the third field, this is for the number of residue of the sequence in the subsequent lines. So let's say this is your PDB structure, and if you look at the PDB structure, when you open the PDB structure, you open with WordPad, okay? You click the PDB and you open with WordPad. Let me just show you here. So if I just double click and then I open with WordPad, this is how the PDB looks like. So if you go to Atom, hang on, yeah. Okay, if you go to Atom, okay. Okay, so if you look at this PDB file, when you go search for the remark atom here, it states that it starts with residue number 1. This is the number of residue, meaning the first residue here, leucine, is residue number 1, and then glutamic acid is residue number 2, and then cysteine is residue number 3, and so on. So L here is 1, so that's why I'm specifying 1 here. Okay, so it really depends on the number of residues in the PDB file. What is the starting residue? And then the next field is just the chain identifier for the protein. So in this case, it is chain A. This is the chain identifier, chain A. So if the protein only has one chain, meaning it's only chain A. If it has two domains, A and B, so you can see that in this PDB file there will be like A, B, C, and so on. It depends on the how many chains or how many domains the protein has. All right. Next one is the last residue. Okay, the last residue of the sequence. So if you look at in this Word document, what is the last residue? The last residue of this protein is ASN, asparagine. So the number of residue is, or the number of amino acids is 61. So that's why I'm putting 61 here. And this is again the chain identifier for that last residue. And the rest of here, you can just leave it blank because these are optionals. But it is crucial to have this 1, 2, 3, 4 colons. Okay, make sure you have these 4 colons, but you can leave all the fields empty. You can put anything. Okay, let me just explain. So the next field is actually the name of the protein. So if you know the name of the protein, let's say it's lipase or hydrolase, you can just type here lipase or anything. Okay, but for me I just leave it blank. And the next field is for the source of the protein. So let's say the lipase is from Pseudomonas aeruginosa. So you can just type in the name of the microbe there. And the next field is the resolution of the crystallographic analysis. Let's say that the crystal structure of this protein was obtained at a resolution of 2 angstrom. You can write 2 angstrom there. Okay, but again, these fields are optionals. This 1, 2, 3, 4, the last 4 fields, they are optionals. And the last field is the R factor of the crystallographic analysis. Okay, now that you have already identified, you have already known all the fields, and you make sure that you have this asterisk at the end of your amino acid residue, for both protein. You need to have this asterisk. Okay, so this will be your alignment.ali file. The most crucial thing here is this code has to be the same. This is the identifier of the protein, and you need to correctly label which one is your template, which one is your target.